Hi, Jennifer. I'm putting this video together to show the thinking process behind the boat of the future, as Claudine have asked for a sample of the thinking process that goes behind the design process. Hopefully, this will save you time because I know how busy your schedule is. And afterwards, if you have any questions, please give me a call or we can set up a meeting. Every design project starts with the discovery phase, and it's defining what the project is. This project is very exciting because it has a very limited time, and it's a topic that I am not very versed into. So I had to do a lot of discovery, and I wanted to pick a boat that I have no idea how it operates. So I finally picked a sailboat. I've never been on a sailboat. So I created that challenge because that's how I get excited and I kind of thrive on learning something new, and especially with the limited time that I have. Legacy or history of a product is extremely important in understanding how did they arrive to these shapes and what made them look this way, and what are the opportunities of changing that. Boats are shaped by being in the water. Like cars need tires, and boats need to have certain shapes to be in the water and to go as smoothly as possible in the water. Same thing, material limitations, and the purpose of the boat, and all of these things kind of contribute to what a boat looks like, and looking into how we change it for the future is we have to look at technologies that's going to be enablers that will allow us to do that. One of the most important things for boats are navigation tools and navigation equipment, and that is what enabled people to sail at night and to places they have not discovered before, is because of these navigation systems, whether relying on the stars, in the ancient times until nowadays, where we have the most advanced computers and control rooms, and now you could probably do everything from a tablet or a phone, navigate across the world just by being in touch with the satellites and being able to do that. So how can we look at the future of navigation and navigation equipment? I think the future of nautical navigation is when all of these equipments kind of talk together and are able to make decisions to make these vessels autonomous, where the satellites are talking to your equipments and sonars and bringing all that together in one device that is going to calculate the weather, the waves, the temperatures, the wind, navigation route, the depth of the sea that you're in, all of that, and make a decision for an autonomous vessel to be able to deploy the sails and take down the sails and kind of know where the sun is at any time, so your solar panels are benefiting the most, and all of that coming together. I think it's going to be the next thing in navigating the seas. After researching navigation and looking into the future of navigation, I went to research propulsion. How do boats kind of move and maneuver, and what are the different propulsion methods there are. For this project, I have selected the inboard jet electrical, driven by electrical motor, to assist the sails. The sails are, of course, the main propulsion because it's a sails boat, but I needed a secondary system because this is an autonomous boat. It needed more than just the sails. This information gave me an idea on what project I would like to tackle as the boat of the future. Learning that average cross ocean small sailboat is about 30 feet, knowing that it has probably 2 to 4 people on it. I wanted to make sure that this autonomous boat that can run day and night while the occupants are either sleeping or enjoying their time. I wanted it to be eco-friendly. I want it to be sustainable. I want the energy to be renewable. Of course, I want it to be safe and fun. The next phase of the research is the inspiration, and what's better to be inspired by than the marine life and how these bodies are shaped by water. Also, birds, especially birds that go into water to catch fish, and also we cannot neglect the nautical themes to be included in looking at a fresh way of tackling the new sail boat. We need to also look at cues from the past. The next phase of research was technology. I wanted to look at renewable technology and sustainable technology, solar panels, wind power, batteries, also flexible materials to be able to mold the solar cells with batteries and creating membranes rather than having the traditional batteries having the body of the sailboat being the battery itself and the surface of the boat being the solar panels, having all of these things as a look in the future of what I think autonomous, sustainable boat of the future would be like. It's very important to look to the past in order for us to understand how the future was formed. When Leonardo da Vinci, one of the great geniuses of his time, was looking at flight, he looked at birds and he had dissected birds and tried to understand flight through birds. And it wasn't until the Wright brothers came and understood lift and the mechanical ways of flight versus the biological ways of flight with birds, and that's when they succeeded. And nowadays, we found the most advanced aviation vehicles look more like birds because we had to kind of relearn everything and kind of evolve into understanding where the advantage of the bird in flight is, which is the shape, not this, not its mechanical apparatus of moving the wings. As we had seen, there was a lot of time invested in the discovery phase, and that's what happens with every project. From that, we gather a lot of information, and then now we're going into the ideation phase of the process where pen touches the paper and we're putting ideas together to select which ones are the most suitable for this project to see the boat of the future. The first thing on this project I wanted to tackle was the mast of the sail. I want it to be completely retractable. I want it to be deployed when it's needed and tucked in for aerodynamics when it's not needed. I wanted it to be used as a windmill also. I wanted a retractable windmill that goes from the inside of that mast and kind of opens up like an umbrella and kind of provide electricity through wind. Also, I wanted to look at the sail itself and the material of the sail. I wanted to make sure that the sail are used as solar panels. And the masts themselves have articulation to be able to take the best advantage of the wind and the sun at the same time. And these are algorithms that need to be calculated at a very high power to see what is the best advantage. Is it the angle of the sun or is it the wind, to be able to harness as much of the energy as possible. The second thing I wanted to tackle is creating a flat bottom boat because of the environmental reasons. I didn't want to harm sea life or coral reefs, and at the same time, that's not very conducive to sailboats, unless it's a catamaran that's really wide. The way that I have looked into tackling the balance of the boat while it has sails and without having a keel is through looking at marine life and birds and wings, and how does that provide the balance in the water or in flight. And that can happen when we bring articulating structure that's very flexible, marrying them with membranes of, like we said, solar cells and batteries and very rugged materials, self-healing materials. All of these things are being worked on right now in science, and creating these fin-like or wing-like structure that can be flexible, that can add the balance to the boat without having a keel, and at the same time, like we said, adjust to the algorithm so it can balance the boat in the wind and in the seas, and wherever the best or the most optimum position for it to be. And with all of these ideas, the designer doodles and comes up with sketches to be able to kind of present the idea in a visual way. And one or more of those ideas or sketches are taken to a more mature level where you're looking at different angles, rendering, presenting the visual side of the design. The next step goes into the 3D build of the surfaces. Then after that, you take that into engineering and testing and validation of those ideas, and that's where engineering works extremely closely with the design to come up with the best possible solution. In the real world, a project like this would have a team of engineers and designers and marketing people and many other facets of product development contributions. This was just an exercise to show my thinking process of how I would come up with a product. When Claudine have suggested the boat of the future, I jumped on it. It's a great challenge, and it was a lot of fun. Thank you very much for reviewing the video. And if you have any questions, hopefully we can set up a meeting together so I could answer these questions. Have a great day. Bye bye.